The tiny flowers seem real, but they are not. This is a close-up photo of a chrysanthemum flower covered with water drops. The tiny flower images are reflections in the water drops. What causes images of the flower to appear in the water drops? Why do reflections appear in the water, but not on the flower? How does matter affect the way you perceive light? What is light? Suppose you are taking a tour of a cave below Earth's surface and the lights go out. Would you see anything? No. You could not see anything because there would be no light for your eyes to perceive. Light is electromagnetic radiation that you can see. Electromagnetic radiation has wave properties and particle properties. A particle of electromagnetic radiation is called a photon. The frequency of a light wave depends on the amount of energy carried by a photon of light. Light waves can carry this energy through space and some matter. Sources of light. You can see an object if it is luminous or if it is illuminated. Luminous objects, such as the campfire in Figure 1, release or emit light. The sun is luminous because it is made of hot, glowing gases. A traffic light and a firefly also are luminous objects. Luminous objects are sources of light. We also can see illuminated objects, such as the camper and trees in Figure 1. However, they do not emit light and are not sources of light. The moon might appear bright, but it is just a rocky sphere. You see the moon because it reflects light from the sun. Reflection is the bouncing of a wave off a surface. In a dark cave, there is no light to reflect off objects, so you cannot see anything. Key concept check. What are some sources of light? How light travels. Light travels as waves moving away from a source. Scientists often describe these waves as countless numbers of light rays spreading out in all directions from a source. You can model light rays by shining a light through a comb, as shown in Figure 2. What are the spaces between the rays in Figure 2? They are shadows or places with less light. The shadows show that light normally travels in a straight line. However, objects in its path can cause light to change direction. It also can spread out slightly as it moves through a small opening. Sometimes, the effect is difficult to see because light waves are so small. Key concept check. How does light travel? Light and matter. What can you see through your classroom window? Would you still be able to see anything if the blinds were closed? How do different types of matter affect light? You can see objects clearly through air, clean water, plain glass, and some plastics. A material that allows almost all the light that strikes it to pass through and form a clear image is transparent. The unfrosted parts of the window in Figure 3 are transparent. Light also passes through the frosted parts of the window, but clear images do not form. A material that allows most of the light that strikes it to pass through and form a blurry image is translucent. Plastics with textured surfaces also are examples of translucent materials. A material through which light does not pass is opaque. No light passes through the chairs or the table in Figure 3. Wood and metal are examples of opaque materials. Key concept check. What can happen to light that strikes matter? Transmission of light. You just read that light passes through transparent and translucent objects. The passage of light through an object is called transmission. The girls and you can see objects through the window in Figure 4 because the window transmits light. A luminous object or an illuminated object on one side of the window is visible on the other side of the window. Also, the energy carried by the light waves from these objects can pass through the window. Absorption of light. Imagine standing near a window on a spring day. The transparent window transmits some sunlight, and it lands on you. If you touch the window, it might feel warm. Some of the energy in sunlight stays inside the window. The transfer of energy by a wave to the medium through which it travels is called absorption. The energy causes atoms in the material to vibrate faster, increasing the temperature of the material. All materials absorb some of the light that strikes them. Absorption of light. Imagine standing near a window on a spring day. The transparent window transmits some sunlight, and it lands on you. If you touch the window, it might feel warm. Some of the energy in sunlight stays inside the window. The transfer of energy by a wave to the medium through which it travels is called absorption. The energy causes atoms in the material to vibrate faster, increasing the temperature of the material. All materials absorb some of the light that strikes them. The window feels warm because it absorbs some of the sunlight's energy. Reflection of light. When you look at a pane of glass, you sometimes can see an image of yourself. Light bounces off you, strikes the glass, and bounces back to your eye. Recall that the bouncing of a wave off a surface is called reflection. Look again at the window in Figure 4. Notice that you can see the transmission and reflection of light. You cannot see it, but some of the light also is absorbed. Most types of matter interact with light in a combination of ways. Light and color. Recall that visible light is electromagnetic radiation with wavelengths of all colors of the rainbow. The longest wavelengths of light appear red. Violet has the shortest wavelengths. Other colors of light have different wavelengths. White light is a mixture of all wavelengths of light. How does this account for the colors you might see? Colors you see result from wavelengths of light that enter your eyes. When you look at a luminous object, such as a campfire, you see the colors emitted by the fire and glowing logs. What happens when you look at an illuminated object? That depends on whether the object is opaque, transparent, or translucent. Opaque objects. Suppose white light strikes a box of crayons, as shown in Figure 5. Each crayon absorbs all wavelengths of light, except its color. For example, the green crayon absorbs all colors except green. The green wavelengths reflect back into your eyes, and you see green. The red crayon absorbs all colors except red, and it reflects red. The black crayon absorbs all colors. The color of an opaque object is the color of light it reflects. What do you think would happen to the colors reflected by the crayons if red light, instead of white light, were shining on them? Would the green crayon still appear green? No. It would absorb the red light, but there would be no green light to reflect. The green crayon would appear black. The blue crayon would also appear black. The red crayon and the white crayon would appear red because they would reflect red light. The color you see always depends on the color of light that the object reflects. Transparent and translucent objects. Absorption, transmission, and reflection also explain the color of transparent and translucent objects. For example, suppose white light, such as sunlight, shines through a piece of blue glass. The glass absorbs all wavelengths of light except blue. The blue wavelengths pass through the glass to your eyes. If the blue glass is translucent, it still only transmits blue light, but the image is blurry. The color of a transparent or translucent object is the color it transmits. What color would you see if you held a piece of red cellophane or a red filter in front of each crayon in Figure 5? Remember that the color you see depends on the colors in the light source, the absorbed colors, and the colors that reach your eyes. Combining colors. Have you ever mixed several colors of watercolor paints to get just the shade you want? You know that you can make many different shades from a few basic colors. If you mix too many colors, you get black. Why does that happen? Combining pigments. Each color of paint in a set of watercolors contains different pigments or dyes. Each pigment absorbs some colors of light and reflects other colors. Mixing pigments produces many different shades as certain wavelengths are absorbed and fewer colors are reflected to your eyes. As you add each color of pigment, the mixture gets darker and darker because more colors are absorbed. Cyan, magenta, and yellow are the primary pigments. Combining equal amounts of these pigments makes black, as shown in the center of the artist's palette in Figure 6. Combining colors of light. Red, green, and blue are the primary light colors. If you shine equal amounts of red light, green light, and blue light at a white screen, each color reflects to your eyes. Where two of the colors overlap, both wavelengths reflect to your eyes and you see a third color. Where the three colors overlap, all colors reflect and you see white light, also shown in Figure 6. Key concept check. Why do objects appear to have different colors?